Ever tried finding a specific moment in a long video, like when a character says, "The secret is in the red house," but the video's too long to scan? You're not alone. Researchers are tackling this exact challenge with a clever new approach called VSI, short for Visual-Subtitle Integration. Let's break down how it works and why it's a game changer for understanding videos. So here's the problem: long videos are huge. Think of a 2-hour movie or a documentary with hundreds of scenes. Traditional AI methods try to handle this by picking keyframes, a few critical moments, to analyze. But here's the catch: they often miss the mark. Why? Because they struggle to connect text queries, like, "What color is the house?" with the actual visuals and context in the video. It's like trying to solve a puzzle with half the pieces missing. Enter VSI. This method doesn't just look at the video, it listens to the subtitles too. Imagine you're watching a movie with closed captions. VSI acts like a detective, using both the visuals and the text on screen to find the exact moments that answer your question. How? It uses 2 streams of processing. 1. The video stream. This part uses AI to spot objects and scenes, like a red house or a person in a white shirt. It leverages convolutional neural networks, CNNs, to detect spatial features, and recurrent neural networks, RNNs, to track temporal dynamics across frames. 2. The subtitle stream. This deciphers the text, matching phrases like, "The secret is in the red house," to the right frames. It employs natural language processing, NLP, models such as BERT or transformers, to parse semantic relationships between text and visual content. Think of it like reading a script while watching a play. If the actor says, "Look at the green door," your brain instantly connects the words to the visual. VSI does this digitally, combining text and video to pinpoint answers faster and more accurately. The numbers speak for themselves. On tasks like "What color is the house?" VSI nailed it 40% of the time, nearly double previous methods. For complex questions requiring both text and visuals, it boosted accuracy by over 15%. And here's the kicker: it doesn't need extra training. You can drop it into existing video systems like a plug-and-play upgrade. So why does this matter? Imagine AI helping you quickly find that one scene in a documentary, or answering tricky questions about a video essay. VSI isn't just smarter, it's more human-like, bridging the gap between text and visuals. Next time you're scrolling through a long video, remember, behind the scenes, researchers are making it easier to find the story hidden in the frames. What's one video question you'd love AI to answer? Let me know in the comments, maybe we'll tackle it next. Imagine an AI that doesn't just watch a video, it thinks about what it's seeing. That's the idea behind Frame-Voyager, a clever system that teaches machines to search for specific moments in a video, just like a librarian finds a book on a shelf. Instead of staring at every single frame like a detective with no clues, the AI learns where to focus. It asks itself, where's the action? Where's the important stuff? This smart searching makes everything faster and more accurate, like having a super efficient assistant who only checks the pages that matter. But here's the cool part. This approach ties back to something we talked about earlier: iterations. By making fewer, more targeted checks, the AI avoids wasting time on irrelevant details. It's like solving a puzzle by looking for the edge pieces first instead of flipping through every single one. Now, this isn't just about speed. Researchers are also pushing AI to handle real-time video, like live sports broadcasts or security cameras. That's where things get tricky. Real-time data doesn't wait. It's constant, fast, and full of surprises. Papers like RTV-Bench are building models that can keep up, adapting on the fly to track moving objects, recognize faces, or even predict what happens next. These systems aren't just watching videos, they're interacting with them moment by moment. Together, these advancements are making AI smarter, faster, and more practical for the world we live in. And that's just the beginning of how machines are learning to see like us, or maybe even better.